Welcome back. This is the second lesson recording for IM1, October 20th, 2020. So where we left off, we finished talking about the slope and equation, and now we're going to go back to the total race and new saga. And this, if you recall, the last lesson we said if the turtle is racing at 3 feet per second and had 2 feet head start, what would be the equation to represent her distance from the start line as a function of time? Okay, so to do this, you need to be thinking about what is the unit rate and what is the starting point. Okay, so and remember y is equal to mx plus b. Okay, m can represent the slope, m can represent the growth in the tile growth pattern, or it can also represent the speed, or it can represent the unit rate. So m in this case is talking about the speed. What is the speed? It is 3 feet per second. So it's 3. M is 3. And what is the starting point? It's 2 feet. Okay, so B is 2. So putting it together, y is equal to m is 3. So we still need to have the variable x plus 2. So this is going to be my equation. Okay, where x is the input, the time, and y is the distance. Okay, and this time I want you to try this. Okay, we did the same problem, but I want to see what you can remember. A turtle's race is racing at 5 feet for every 2 seconds and had 3 feet head start. What would be the equation to represent her distance from the start line as a function of time? So again, to do that, you need to start by, because we need y is equal to mx plus b, we need to be thinking about what is m, what is b. Okay, so what is m is 5 feet for every 2 seconds. We don't want it for 2 seconds, we want it for 1 second. So what do I do to 5? I need to divide by 2, so m is 2.5, 2.5. Okay, and right next to that is the variable x. This is not multiply sign, this is variable x plus, what's the b? That's the starting point, right? And it says that it's getting a 3 feet of starting head start. So he's starting 3 feet ahead of the starting line. So the equation becomes y is equal to 2.5x plus 3. Okay, all right, so how about this one? Answer in private chat for me. Okay, which turtle has the head start? And then which turtle has a faster speed? And which turtle has, if the race is 8 feet, who wins the race? And then finally, if the race is 12 feet, who wins the race? Okay, so the first answer is which turtle has the head start? The red graph is starting not at 0, 0, which represents the starting line, but it's starting at 4 feet away from the starting line. So that has the head start of 4 feet. Which turtle has a faster speed? The speed is really how fast it is the steepness. Which graph is steeper? Okay, it's the blue one. Okay, why is that going faster? You need to be thinking about unit rate. So every time x increases by 1, okay, how much does y increase? It increased by 1. Okay, so every time x increases by 1, the blue turtle is increasing by 1. That means he is traveling at 1 feet per second. Okay, what about the red in contrast? Every time he you have 1 minute or 1 seconds, 1 minute passes. How far did it go? Less than a foot. Okay, maybe like a half, maybe 2/3 or something like that, less than a foot in compared to 1 foot here. So the blue turtle is going faster because it is steeper. If the race is 8 feet, who wins the race? So if the race is 8 feet, that means we just need to figure out who reaches this 8 feet line first. Okay, who reaches the 8 feet line first? Well, the red turtle does, right? And the blue turtle comes. Red turtle gets there a little after 6 seconds. The blue turtle gets there at 8 seconds. So the red turtle will win. Okay, and what if the race was 12 feet? Who would win the race? Okay, so then in that case, I could say 12 feet. Where is 12 feet? Y is 12. So it is over here. And let me move my thing. Here we go. And looking at this, who gets to this 12 feet first? It's the blue turtle. And then followed by the red turtle. Okay? So, who wins the game or who wins the race really depends on how long is, how far is the race. If it's a short distance like 8 feet, the red turtle will win first because he's going to get there first. Because although he's slower, he had a head start. But if it is longer race like 12 feet, then because blue is faster, it's going to take over the red turtle and get there faster. Okay, so let's talk about the Unit 2 test. Well, it's going to be on linear relationship, recognizing slope and y-intercept in graphs, equations, and table, and interpreting meaning of slope and y-intercept in tau pattern, racing, and additional situations. And simplifying exponents, including zero and negative exponents. So this is new. And Unit 1 material. Okay, any of the Unit 1 material is a fair game. That means solving equations, simplifying absolute values, and using function notations and domain and range. So let's just talk about what we have figured out in linear relationship. Okay, so a linear relationship, whether we're talking about a tau pattern, or whether we're talking about a turtle race, or whether we're talking about any other growth or changes, it's always going to have the starting value and it's going to have the growth rate. Okay, so let's think about a situation. Okay, so what about tau pattern? When you did tau pattern, what was the starting value? Starting value was the number of tiles in figure 0. Okay, what was the growth rate? Well, the growth rate was how many tiles were being added each tile figure number. What about in race? Okay, so we did the race. Well, distance, time, and speed were all the things that we were dealing with. So distance was the output, time was the input, and then speed was the slope, right? Or in this case, it will be the growth rate. Okay, and so in this case, what represented the starting value? It was actually the y-intercept or starting head start. Where did he start? Okay, so again, tau pattern is going to be number of tiles in figure 0 and growth per figure in the growth rate. And for race, it's the number of feet of head start where he started off with, and then finally the slope is speed in feet per second or meters per second or meters per minute or whatever else the unit is. Then we talked about table. If you had a table of values, then can you represent this as a linear relationship? And can you come up with an equation? Okay, so in this case, what was the growth? Well, every time x increased by 2, y increased by 6. Or every time x increased by 1, y increased by 3. So if x is increasing by 2, then you need to divide whatever the y is increasing by, divide by 2. Okay, so to get the unit rate. We don't want, every time x increases by 2, we want to know when x increases by 1, which is the 1 unit. And then we went on to graphing. And where does this, so growth rate is represented as slope, and then starting value is represented as the y-intercept. Okay, and here we have the y-intercept being represented here and the slope being represented in this slope triangle. And then finally we went on to equation where y is equal to mx plus b, where slope is represented by the growth rate and then b is represented by the starting value. Okay, so how are you going to be studying for the test? Well, you are given the review packet. The first 2 pages were given out to you as homework that was due last night. Okay, the linear relationship continues in page 3, and then on page 4 you are going to be simplifying exponents, and then page 4 to 6, or second half of 4 to 6, is more of review from unit 2 that you need to refresh your mind. Okay, so you do need to do all of this because I'm going to give you some time during the class as well as over the next couple of days. That's going to be your homework. And you should also be looking at previous quizzes and unit tests. I have opened up all the unit tests and all the quizzes so that you can click on any of them and you can see your answers, the correct answers, and you might start to think about, okay, what did I do wrong? And that is really important because if we do not recognize what we did wrong, you're most likely to be making the same mistake again. You should also be looking at the notes that you've been taking, so such as the formula definitions, and you should also be looking at the comments from the homework because I am going to be giving you feedback about what are some of the common mistakes in my annotations. I am offering an extra study hall on Wednesday. That's tomorrow. That's the outreach day, but that's going to be during lunchtime between 12 and 1 p.m. or by appointment. Okay, so right now I am going to give you time to start working on page 3 and 4 of the review packet. If you have not done page 1 and 2 as part of your homework, then you should be starting on page 1 and 2. Okay, if you're not sure about any of the problem, you can certainly ask me in chat and I'll try to answer for you. And if there are many people asking the same question, I might put the whole class together so that we can do it together. Let's do a few more reviews. Okay, if you're given this graph, okay, you're not given all the values at all, but you need to pick which one is the possible equation for this graph. Okay, so is it going to be y is equal to 3x plus 2, y is equal to 3x minus 2, y is equal to negative 3x plus 2, or y is equal to negative 3x minus 2? Looking at this, what sort of slope is it? Okay, remember, puff positive goes up like this, nice negative, this is 0 fun, undefined. So these are positive, negative, 0, and undefined. Okay, so what kind of slope is it? It's a negative slope. That means which do we want? We don't want positive 3 in front of the x. We want negative 3. So possibly this one or possibly this one. Okay, but then we need to be looking at the y-intercept. Where is the y-intercept? Is it positive or negative? It's positive, okay, because y-intercept is here and 0 is here, and up here is going to be positive number, so we want it to be positive. So this is the correct one. Okay, what about